Howdy YouTube. Many people think that tea contains theine and coffee contains caffeine, and this is somehow a different substance that has a different effect. According to the US National Cancer Institute, theine and caffeine are actually the same molecule. So the question is not to find out what kind of molecules tea, especially green tea, and caffeine contain, but why the stimulation and the effect feel so different. Green tea has gotten a bit of a revolution in recent years because of trends like matcha and people trying to get away from the 6 to 12 cups of caffeine they have in office. But it is mostly misunderstood where the difference in effect actually comes from. I just assumed that green tea had a different stimulant than coffee. But pharmacology suggests it's not the name of the compound that matters, but the concentration found in your bloodstream. But what matters is how much and how fast these molecules enter your bloodstream. Evans et al. Describe the general effects of caffeine. You can think of it as a curve. On the y-axis, you see the concentration of caffeine molecules in your blood. And on the x-axis, you see the time it takes your body to metabolize these molecules, basically getting rid of them. Because caffeine is absorbed rather quickly, concentration peaks within 30 to 120 minutes, and the curve I just described is skewed to the left. So you'd have a rather quick onset of an effect with a prolonged effect on your central nervous system. The average half-life, or the time it takes for your body to get rid of half of the molecules, is on average about 5 hours in healthy adults. The shape of the curve can really differ depending on factors like smoking and pregnancy, we explained before, but also food. Look at this study from Skin et al. In 2013, which examined about 14 healthy and active male individuals that were either in a fasted state or in a state which they were fed with high carbohydrate meals. Both groups were administered with either 6 or 9 milligrams of caffeine and then tested in certain time intervals for their concentration of caffeine molecules in their bloodstream. What the researchers found was that caffeine peaks were reached within 60 minutes for the fasted group in both caffeine uptakes, 6 and also 9 milligrams, while the fasted group had an onset or a peak of caffeine concentration at 120 minutes, while the highest caffeine amount, which I should say is quite absurd, had a peak at even 180 minutes. As you see in the graph, peaks for the fasted group were reached much more quickly, suggesting that high carbohydrate meals prolong and smoothen the effect. So eating before injecting caffeine flattened and also delayed the caffeine absorption curve, even with these very high amounts of caffeine. So to conclude, food actually helps to stabilize the curve, to flatten it, but also to make it more smooth in shape. So the food coma might actually be helpful to stabilize caffeine. But what about the difference of caffeine in tea versus coffee, you may ask? Well, it's the identical molecule that we know. The question now is how much is actually contained in the beverage we drink. If you look at this table, you'll see that green tea actually has the lowest amounts of caffeine with just 29 milligrams per cup, while a brewed filter coffee has almost 100 milligrams of caffeine per cup. Obviously, really depending on how strong you'll make it. What is really interesting in this graph, I think, is that black tea has significantly more caffeine, while you see that energy drinks per cup even contain lower amounts of caffeine compared to a filter coffee, because energy drinks usually come in cups, or cans I should say, of 500 milliliters. So you see that green tea delivers a much lower dose of caffeine compared to all the other beverages, even to black tea, which is just fermented green tea, basically taking away the bitterness and increasing the amount of caffeine content found in it. So you would think, is this caffeine content still relevant? Is the effect so low that it is negligible? I discovered the potential for lower stimulation somewhat accidentally. My old boss recommended that I should substitute green tea for my average espresso, 1 or 2, after lunch. And what I found was an interesting effect. The overall stimulation was lower, but my focus was much more stable and more balanced, almost calm. That very observation led me down the rabbit hole, which eventually led to green tea research. If you want to test it yourself, try this experiment. You'll swap all or some of your coffee with green tea. 1 or 2 cups should generally be enough. Pay attention to jitteriness and focus stability. Also pay attention to when you're going to bed, falling asleep, and how well rested you are on the morning after. You may feel a smaller kick, but also less overstimulation. There are, however, limitations to this, especially if you are a high caffeine user. In a meta-analysis from Giuliano et al., they found that caffeine tolerance usually vanishes 2 to 9 days after stopping even lower or considered lower caffeine uptakes of approximately 100 milligrams a day. But what they also found, that tolerance is having a much more prolonged effect on the human body, which can significantly decrease your effect from the smaller green tea dosages. So what is the takeaway from this experiment, but also from this video? Well, caffeine and theine are certainly the same molecule, but coffee and green tea have a very different effect on the human body, which cannot really be explained by just the caffeine alone, because that is just significantly and substantially lower in green tea. So the real power of green tea can't be explained by caffeine alone. In the next episode, we will have a look at the other contents of green tea that actually stabilize or have an effect on the caffeine itself, the over arousal you will feel, and the ability to concentrate. I invite you to subscribe to the channel and also to check out the blog I wrote for Brain on brain.de. Thank you very much for watching, and I hope the experiment goes well for you.